So the title of this concept is quite the mouthful. Rational expressions, adding and subtracting them without common denominators. So it goes back to everybody's favorite thing, fractions. So like if we have, let's just remember, if we have 2/5 plus 3/4, we know that in just plain old fractions, we're going to add the tops. So that's good. But we can only do that if we have common denominators, which here we don't. We have a 5 and a 4. So we're going to ask ourselves, what common denominator do we have? Well, in this one, we don't have a common denominator, and we can't just simply multiply, like we can't double 4 or we can't triple 5. We have to multiply both of these by a completely different number to get a common denominator. So I think we can pretty quickly see our common denominator is going to be 20, right? They're both factors of 20. So we're going to multiply this whole side by 4, right? Because 5 times 4 is 20. And on the other side, we needed to multiply by 5. So these numbers, what we multiplied by, is not the same. And that's totally okay. So we need to do the same to top and bottom. So 2 times 4 is going to give us 8 plus, and over here, 3 times 5 is going to give us 15. Okay, so good. So we've got 23 over 20, because after that our normal process stands that we don't change the denominator, and we only add the numerators. Okay, so I think we just finished grade 8 math with that. We are going to apply this exact concept to rational expressions. We have to find a common denominator, but this time our common denominators are going to look like an 8x and an x, right? Or maybe we're going to have x plus 1 on the bottom and x plus 3 in the other one. So that's kind of where we're going, but we're going to apply the same process of multiplying by something to reach a common denominator. So let's try one. Let's say we've got 2 over 8 plus 1 over 8x. So look at these common denominators. They are not the same, but they're awfully close. Is there something I can get to relatively easy that would be common? And you're right, it would be 8x. And to make that common denominator, I just need to multiply this side by x. And over here, I didn't multiply by anything. I just left it. So if I do that to the top, on the top I'm going to get 2x. And over here I still just have 1. And what happens when I add those together? Well, 2 and x do not add because they're not common, they're not like terms, and that's okay. So our answer is going to be 2x plus 1 over 8x. Not bad. You cannot factor or cancel out that x, remember, because it has not been factored out. So this is your final answer. Okay, let's try one that's maybe a little next level. So 7 over 3x minus 2 over 5. Okay, we do not have common denominators. In fact, there's not something that I can just multiply one of these by to get the other one. So instead, similar to that first problem with 5 and 4 in the bottom, I'm going to multiply them together. That's always a quick and easy way, is to ask yourself, what is 3x times 5? Well, it's 15x. So if I make 15x my common denominator, the question is, what did I multiply by over here? And you multiplied by a 5. So if I do that to my 7 times 5 is 35. we're subtracting. On this side, what did 5 multiply by to become 15x? And it multiplied by 3x. So 2 times 3x is 6x. So now now that I have common denominators, I can subtract. These are not common. These are not like terms. So I'm just going to have 35 minus 6x over 15x. Now ask yourself if there's anything in the top that you could factor out and cancel. I don't think you're going to get any common factors here, 3, 5. So that's going to be your answer. Okay. Let's keep going. What about this? 3 over 2x plus 6 plus 4 over 6x plus 18. Okay, so we've reached a new level here. Now you've got a binomial in the denominator. When you see a binomial in the denominator, your best bet is to factor. Do you see a theme? Factoring is usually the best first step. So let's see if we can rewrite these denominators factored. So 2x plus 6, they both have a 2 in common. If I factor out a 2, I'm going to get x plus 3. And over here, 6x plus 18. If I factor out a 6, they both have a 6 in common. What happens if we factor out 6? Take out the 6, and we're left with, x plus 3. Okay, so this is interesting. I haven't changed anything. So my 3 is still in the numerator, and so is this 4. Now, really, this is like saying 2 times, I shouldn't write that. This is like saying a 2 times an x plus a 3, right? In this 6, I can break my 6 down and call that a 2 times a 3 times x plus 3. So now if I compare this to this, is there something that's common? They both have 2's, they both have x plus 3, except this 3. So what if we multiply this side by 3? Okay, if we multiply by 3 over here, oops, my 3 doesn't look like 3. What's that going to give me? I'm going to add this 3 to the bottom. So now I'm going to have 2 times 3 times x plus 3. And then 3 times 3 is 9 plus 4. And this is still my 2 times 3 times x plus 3. So now I have a common denominator. I can go ahead and put these together as a 6, how they were. So 6 times x plus 3. And in the numerator, I now have 9 plus 4, which is 13. Ask yourself, can these cancel or simplify? They can't, so we're just going to hold those. And we're done. Okay, so let me recap what I did here. I factored. When I saw a binomial, I factored. And then I was able to kind of break that down because I had the same bracket. And they both had a 2. But this has a 3. So I multiplied this side by 3 in order to get that 2 times 3, which would give me the 6. So then I would have a 6 times x plus 3 on both sides. Okay, let's try another one. Let's try 2x plus 3 over 5x minus 30 minus 3x plus 4. Ooh, this one's already looking a little complicated. Over x minus 6. Okay, again, binomials. 1 term, 2 term, binomial. Factor. X minus 6 is kind of my goal here, right? I'm thinking I can make this happen. So this has a 5 in common. So if I factor out a 5, I do, sure enough, get x minus 6. The 2x plus 3 is still in the top. The 3x plus 4 is here, and my x minus 6 is here. So now the question is, what's the difference here? They both have an x minus 6, but this one has a 5. So over here, I need to multiply this whole thing by 5. This still hasn't changed. Haven't done a single thing to it. But over here, I'm going to multiply by 5. So in the bottom, it's just going to look like this to make that match. And in the top, I'm going to multiply the top by 5 too, but I need to put my 3x plus 4 in brackets. I'm going to have to distribute that 5. So now that we've got a common denominator, we can combine this into one big function. So 5 times x minus 6. Now remember in the last lesson when we talked about this negative, it means you have to subtract both pieces, but I also need to distribute here. So I'm going to have to make this 15x and 20. So if we start way over on the left, 2x plus 3 minus, this is 15x, so minus 15x. And right here, remember we said 5 times 4 is 20, so minus 20. Okay, now we can combine like terms. I've got x's and I've got whole numbers. So this is going to become 2x minus 15x is negative 13x. 3 minus 20 is negative 17 over, I'm going to go ahead and put my 5 back in, 5x minus 30. 13 and 17 are prime, so there's nothing I'm going to be able to factor out and simplify. So that is our final answer. So just to go through that one more time, I factored out my 5. I multiplied this side by 5 to get common denominators. Because I had a binomial in the top, I put it in brackets to multiply it by the 5. And then we had to distribute the 5 in to the bracket. And we had to subtract everything. So we had to subtract 15x and subtract 20. We collected our like terms and landed on our answer. Okay, let's try another one. What if we have 2 over x plus 3 plus 4 over x squared plus 4x plus 3? So our new wrench in this one is we've got this trinomial. So again, we need to factor. Factoring is almost always the best first step. So not much we can do here, 2 over x plus 3. But if I factor this, what two numbers multiply to 3 and add to 4? 3 and 1. So x plus 3 times x plus 1. And if I put brackets over here, it becomes really clear that this side needs an x plus 1. So we're going to multiply this whole thing by a bracket, which is allowed. You can totally do that. So if we do that, we get 2 times x plus 1 and x plus 3 times x plus 1. And the other side hasn't changed. Hasn't changed a bit. So just kind of like this last problem we just worked, we need to distribute that 2. So now that the whole denominator, is the same, we can combine this into one giant addition problem. So we're going to have one giant rational expression with x plus 3 and x plus 1 in the denominator. I'm going to multiply the 2 times the x. So 2x, the 2 times the 1, plus 2, and then over here I have plus 4. So after I do all that, I get 2x plus 6 equals x plus 3 times x plus 1. And then I'm going to ask myself, is there anything I can factor out here? I think I can factor out this 2. So if I factor that out, I get 2 times x plus 3. and x plus 3 times x plus 1. And now, lo and behold, what do I see here? I've got brackets that match in the top and the bottom. So I'm going to cancel those. And I'm left with 2 over x plus 1. Okay, so the important piece of this is that we can multiply by an entire bracket in order to get a common denominator. Now, the very final piece, the final level, is going to kind of put all of that together. All right. If we've got 3 over x plus 2 plus 4 over x minus 7, we're back to where we started with nothing being common. Like I can't double this or factor something out. So remember, when you've got two numbers that have nothing to do with each other, like 1/2 times 2/5, 2 and a 5 don't have anything to do. So what you do is you multiply them together, right? And you get 10. So over here, on that same line of thought, all we can do is multiply these together. X plus 2 times x minus 7, right? That's really the only way we can get a common denominator. So that means that this side needs to multiply by x minus 7, and this side needs to multiply by x plus 2. So I've already done that in the denominator because I already wrote it right here. So now I'm going to do that to the top. So I'm going to have 3 times x minus 7. And over here I'm going to have 4 times x plus 2. And once that's done, we're going to put this all together. And in the bottom we know we've got x plus 2 times x minus 7 because we finally have common denominators. Then I'm going to have to distribute 3x, and then 3 times negative 7 is negative 21, plus, this is addition, so that's easy, 4x plus 8. Collect our like terms, and we have 7x minus 21 plus 8 is negative 13. Oops. Negative 13, and in the denominator, I have x plus 2 times x minus 7. 7 and 13 are prime. There's no way I'm factoring anything out of there, so be it. Unless I added wrong. Nope, I think we're good. And that's it, folks. We're done. So the recap. You can multiply by brackets. If your denominators don't naturally have something really quick and easy to find, at the very least, you multiply them together. If it's ugly, it's ugly. Make sure you distribute through a bracket. Be careful of subtracting if you need to distribute that subtraction. If you're adding, no big deal. Always check at the very end to simplify. Cool, good job.